Okay, here is a quick video on linear programming for those of you that are still struggling. I pulled this from another packet that we have had, so it's something new so you can use it to relate to the one that you have in your review packet. The very first thing I would suggest when working on this is to go ahead and circle all of the important numbers. And for us, I mean, in math, we're just looking at the numbers anyways. Most of the other stuff is kind of useless information. So, I've gone through, I've circled all my numbers, okay? The very next step that I'm going to go through is I'm going to actually read the very last sentence to find out exactly what we're talking about, because I need to label my variables here. So, the very last sentence says, how many of each type of building should Bob use to maximize his profit? Okay, well, what am I talking about? What kind of buildings? Well, I'm talking about a small shed and a large shed. So from this point on, I am going to label, every time I see a small shed, I'm going to assume that that's my X, and a large shed, I'm going to assume that that is my Y. Now, the next thing I'm going to start looking at is constraints, and that's using all of these numbers. Well, let's cross out the things that we can write off. Okay, the $390 profit on a small shed and the $520 profit on a large shed. So anything that has to do with money, that's going to be part of my objective function. So I'm going to go ahead and use those first so that I can kind of eliminate some of the useless information here that's in here. So $390 on a small shed. Well, remember, small shed was my X, so that's $390X. Okay, so that's what I make profit on, $390X. The other thing that I'm going to be making profit on is $520 on the large shed. Well, remember, large is my Y value, so I could say plus $520 for every Y shed. So I make $390 on the X sheds, the small ones, and $520 on the Y sheds, the large ones. Okay, so I've now effectively used this entire sentence. So now, if that kind of messes you up, it kind of overwhelms you, cross it out. So now I'm going to start looking at the rest of this, and it says, Bob builds his tool sheds, okay? He uses 10 sheets of drywall and 15 studs for a small shed, okay? Well, if you notice, both of those have to do with this X variable. So what I'm going to do is I'm going to start noticing that's two more things we're talking about. So I'm going to start, I'm going to actually put that down here. I'm going to put that over here with my constraints. And I'm going to say that I have a drywall issue and I have a stud issue. Both of those are going to I'm going to have drywall for my small shed and my large shed, but I'm going to have studs for my small shed and my large shed. So that basically, there's going to be an X and Y under both of these equations, okay? So let's see if we can start putting it together. So the 10 and the 15, recognizing that's both with the small shed, so that's 10 X's here and 15 X's here. But if you notice, they're both X's, and that's going to go for those two other equations. So we have 10 for drywall, and we have 15 for studs. See if you can see that a little bit easier. So the next thing I'm going to start looking at is, as I continue throwing, so I've now used this sentence, okay? So now 15 sheets of drywall and 45 studs, so now I'm back to my two equations here, but we're talking about the large shed. So that's 15Y for drywall and 45Y for studs, okay? So now I've finished the rest of that sentence. Okay? So, if I have this much for drywall and this much for studs, I'm going to have to start using my last two equations. So, he has available 60 sheets of drywall. So, if I need 10 for my small shed, 15 for my large shed, it has to be less than that 60. Okay? We can't use 61 sheets. I can only use 60 sheets, so it has to be less than or equal. That takes care of that one. This one, 135 studs, has to be less than or equal to that right there. Okay? So now we've come up with all of our equations, and we're able to get to the point where I can actually start graphing them. Okay, the last thing that we need to clarify before we can exactly start to graph this is to start thinking about X and Y specifically. And this is kind of those standard equations that you need to think about. What do we know about the number of small sheds, and what do we know specifically about the number of large sheds? Well, everybody knows you can't make negative numbers of anything. You are producing something. You can either produce 0 or you can produce more than 0, but you can't produce negative numbers. So the other things that we need to include as part of the constraints is that X has to be greater than or equal to 0, and also Y has to be greater than or equal to 0. So now we're at the point where we can start to graph this. Now, if you are comfortable with changing this and manipulating this into slope-intercept, may I suggest you go ahead and do that. So you would subtract 10x from both sides, divide by 15. Same thing here, subtract 15x from both sides, divide by 45. You're going to get some odd fractions, and it will kind of get a little bit confusing when you go to scale here. So one of the things that I always suggest is doing X and Y intercepts. It's a little bit easier. I call it my fat finger method because you're basically plugging in 0 for X and 0 for Y to find your respective your respective intercepts. So if I put my fat finger over X, that's the same thing as plugging in 0 here, okay? And I solve for Y, so I would say 15Y is equal to 60, so I would know that my y-intercept is 4, okay? And then if I do the same thing and put my fat finger over the y value, and I get 10x is equal to 60, I know my x-intercept is 6, okay? These are a lot easier numbers to graph. I'm going to do the same thing when it comes to this equation, and I put my fat finger over my x value, and I say 135 divided by 45. I know my y-intercept is 3. And then if I do the same thing here, that I say 135 divided by 15, my y-intercept, or my x-intercept is 9. Okay? It's just like solving a one-step equation. Well, at this point, I am just going to graph all of the points that I have listed. So I know that nothing can be negative here, so as I go to graph and set this up, nothing can be negative. I'm only looking in quadrant 1, so I kind of mark it out. Well, this one's kind of easy because I know I have to graph somewhere up here, right? Because it has to be greater than x and greater than y. So I know I'm going to be graphing or shading somewhere in this vicinity. And that already told me I didn't need to plot anything in quadrant 2, 3, or 4. So now I'm going to start looking at my x and y intercepts. So I have a y-intercept at 4 and an x-intercept at 3. Notice this is going to be a solid line, and I'm shading below. And I'm going to actually, instead of using pencil here, I'm going to go ahead and use a colored pencil so it's a little bit easier to see. So I'm shading everything below that line. Now I'm going to go ahead and graph this one, a y-intercept of 3 and an x-intercept of 9. So that's going to put it right there. Once again, solid line because that tells me it's equal to. Okay? Now, when I go to do this one, take note that when you're looking at this, although this one, they kind of cross, this one does extend out a little bit further. So, you get something, and I hope you can see it a little bit. You get something that looks like that. So, in this scenario here, in this little section, it's only green. In this little section, it's only pink. Okay? But if you notice, if you draw the line here, there's that's that little point where it crosses. So I get this area here. Okay? And above 0, and above 0 that way. So that's what I'm getting. Those are my vertices. So I have this corner this corner, and of course this one. And that is what we're going to test when we go to look at this. So, when I look at it, I say, okay, what are all the possibilities? So, what are the vertices? Well, it could be 0, 0. It could be this one here, which would be 0, 3. It could be 3, 2. Or a possible solution to maximize would be to 3, 6, 0. So, these are all the possibilities, and you do need to check all of them. So, what's the only equation that we haven't used yet? That's profit, right? We're seeing which one of these maximizes my profit. So, I'm going to plug this in for my x and that in for my y into my profit equation. So, if you remember my profit equation, I'm going to say 390 times 0 plus 520 times 0 equals what? Well, obviously 0 and 0, that would give me, if you don't make anything, you can't make profit on anything. Well, we have 390, if I make 0 of that small shed, and I make 520 on that one, I say 520 times 3 gives me $1,560. Okay, so the next one, I would say 390, plug in the 3 sheds there, 520, the 2 sheds here. So 390 times 3 and 520 times 2, and I get 2,210. So far that one's looking pretty good. 390 times 3 and 520 times 0, and you get 1170. So, when this question asked, the original question was, how many type of each building should Bob build to maximize his profit? Oh, I think it's kind of simple to see here that if I make, that this one obviously results in the best equation, press profit. So my max profit is $2,210 when Bob builds 3 small sheds and 2 large sheds. I hope this was a little bit easier, and it lets you see how you work it all out, starting from the very top and circling what we have information-wise, going through and labeling all of your variables, writing out your equations, doing out vertices, and then answering the questions out at the very end. Please send me a message if you have any questions.